Now it's time to enter the sensory world. Humans are about 80% visual, relying upon the other senses for the remaining 20%. Of course, if you are blind, then your orientation in this world has been shifted to other senses like auditory or touch. The sensory system is interesting. It is how we know the world. Let's start with our skin. The skin has 6 kinds of receptors that sense touch, temperature, movement, and others. Some have straightforward names, such as free nerve endings or corpuscle of touch. Gee, wonder what they do. While others are a bit wacky, like laminated corpuscles, I should say, or organ of Ruffini. You can find all 6 of these on page 25 of your objectives, and in the diagram on page 564 of your textbook. These skin receptors are called cutaneous receptors because cutaneous means skin. Imagine that. Be sure to also see the slides of the models on the Q drive that shows some of these receptors, and then look at the actual models in lab to practice. Now take your pencil or pen, or better yet, get one of the famous wooden pointers. You're going to need one of those anyway when you look at the models. And touch one of the hairs on the back of your arm. Maybe you're a swimmer and you don't have any hairs on your arm. Did you shave them? If you have hairs on the back of your arm, notice how sensitive that one hair is to touch. Just touch just one hair. What cutaneous receptor allows you to feel that sensation? Can you imagine how this adaptation might be significant in our survival? By the way, as I'm recording this, how ironic. I just detected a true bug who landed on the back of my arm. What's the name of that hair sensor again? Oh yeah, the hair root plexus senses the movement of the hair. So how is it that a true bug came to alight upon my arm here in this little recording studio of mine? Well, it didn't. But as I wrote the script or thought about what I wanted to say on this audio, I was sitting under a beautiful oak tree out at Pozo on a little picnic table. And that's where the flies were buzzing and the true bugs were flying about. And one of them landed on my arm. Man, it was beautiful out there that day. As you can see, touch is one of the general senses. Temperature is another. There's a group of 5 senses that are called special senses and are housed only in the head. The special senses are you ready? Olfactory, which is smell. Gustatory, love that one, gustatory, which is taste. Kind of reminds me of Willy Wonka when I say that one. Gustatory, for taste. Vision, equilibrium, and hearing. Let me make that list again. The 5 special senses that are housed only in the head are olfactory, gustatory, vision, equilibrium, and hearing. Let's take a closer look at olfactory. This sense organ is housed, of course, in the nose. What is the pathway of olfaction? Open the Q drive and find the tracing of this olfactory tracing there. Then turn to page 567 of your textbook to follow along there. So what happens? Well, air containing chemicals enters the nostrils and is pulled to the roof of the nasal cavity. There, odor molecules contact the olfactory hairs, which in turn trigger an impulse along the olfactory neurons. Now, the number of molecules needed to start this reaction depends upon the chemical. We are more sensitive to some molecules than others. In other words, we can smell some molecules while we can't smell others. How is it that a dog can smell things that we can't? Well, they have more olfactory hairs packed into a small area, and they have olfactory hairs that are sensitive to different chemicals than humans are. So then that impulse that's traveling along the olfactory neuron travels through the cribriform plate of the ethmoid bone. Remember our old friend, the cribriform plate? You remember where that is? On the base of the skull, when you open the skull up and look inside the brain case. The sensation travels to the olfactory bulb and then along the olfactory tract. The sensation of smell first is in the olfactory cortex of the temporal lobes of the cerebrum. And we might say that's where it ends. But actually, later, sensations may be sent from the olfactory cortex of the temporal lobe through to the thalamus and to the frontal lobes for further discrimination of odors, so we can interpret those odors more closely. Nothing is really simple when referring to the interpretation of our senses or our sensory system. Thus, you have the ability to detect all those wonderful odors out there. Of course, there are some you just as soon not detect. Sorry about that. So put the sensation of olfactory and the tracing all together by using the Q drive and looking at the diagram in your textbook.